Okay, hello students. My name is Mr. Kamulegeya Jonathan. I'm the teacher of mathematics. We are discussing multiple vectors. We did a number of numbers, and basically today we are going to do what we call a geometrical vector. We have one number on our blackboard which we want to work out to see how we can really get its solution. As you can see, basically this number is saying in the diagram below we have OA. Our OA is this one here. This is OA. And then OB, O to B, the direction, and its vector is B. And also we have BC. We have BC is equals to 2OA. We have BC is equals to 2OA. This is our BC. B to C, the same as 2 to OA. Therefore, from here to here is 2A. And then we have 3OB. 3OB. OB is equals to 2OE. We shall see how we can use that, that point there. And then they are telling us that BC, F is a midpoint of BC. This F is a midpoint, meaning that here it is 1. So here it is 1. This F is a midpoint. It divides the line BC into two positions. And then they are telling us that G divides AC by AC in the ratio of 2 to 1. It's going to be 2. A to C is going to be 2 to 1, meaning that here we have 2 and there we have 1. I think we have interpreted our question. And then they are telling us we should find the value of CB, we find the value of AC, and the value of BE in terms of A and B. Let's see how we can really solve out this question. We can start by solving what we call CB. CB. Start by CB. You know that CB, CB. To get CB is the same as saying but. We know that. CB, we know that. Here we know that BC is equals to 2A. 2OA. In this case, our BC will be the same as 2 times our A, it is 8. Meaning that BC to be the same as 2A. But the question wants us to get CB. CB is going to be negative of BC. Because here we have C, we have BC, and the question wants us to get CB, meaning that we are moving the opposite direction of BC. Therefore, our CB, it will be the same as negative 2A. And that's our answer. In this case, the vector of CB will be negative 2A. Reason being, we are moving the opposite direction of BC. Then our next part is telling us that we should solve what you call AC. AC. If you look here, in our diagram, A to C. To get AC, you can move from A to O to B, and B to C. Are you seeing that? Therefore, our AC is going to be A to C. We're going to move from A to O, plus O to B, OB, plus B to C, which is B, C. In this case here, we shall come and say, here we have O to A, but in this case we want to get A to O, meaning that our vector A is going to be moving in opposite direction, to be negative. We shall have negative A plus O to B, which is B, plus B to C, B to C. In this case, our BC is going to be 2A. Therefore, here you can collect like terms. We shall have B plus 2A minus A. Therefore, we shall end up having B plus A. In simple term, our SC, it will be the same as B plus A. Let me hope my students were together. Here I was able to get what able to get my SC. In simple term, my SC is B plus AB. Now, we need to come and solve what we call BE. BE. Now, if you look here, let's look for BE. BE. That's what we want us to get. B to E. But remember, we have this relationship here which says that, but we have a relationship which says that 2, 3 of B is equals to 2 of E. We can try to get the ratio in this case. If we get the ratio here in this case, it will show us the way forward. Then okay, BE, they want us to get BE. Let's first analyze and see how we can come up with that BE there, which we need in that question. Let's first get the ratio. Here it breaking by OE, here by OE, this goes to 1. We shall end up having by 3 here, this goes to 1 also. We shall have OB out of OE is equals to 2 out of 3, meaning that we have the ratio of OB to OE as 2 to 3, meaning that O to B is supposed to be 2, therefore there is 2, and O to E is supposed to be 3, meaning that here we have 1. Since from here up to here it is 3, and from here up to here it is 2, meaning that from here up to here it's supposed to be 1. But the question is interested in getting BE. Getting B what? BE. Getting BE. Getting BE. How can we get our BE, my dear students? If you can look on the blackboard there, we need to get BE. Is it okay? We need to get our BE. We get our BE. We know that BE, shall start by saying BE is going to be the same as saying 1 out of 3 of OE. This BE is equals to 1 out of 3 of OE. Now, we should get our OE. But remember here, OE, but we know that from this relationship here, 3 of B is equals to 2 of E. I say that, meaning that OE to be the same as saying 3 out of 2 of B. Since we have our OB here, it is B, therefore we shall say OE is equals to 3 out of 2 times B. Since we have our OE here, we can come and substitute our OE in this expression. I say that we shall say BE is equals to a third times 3 out of 2B. Therefore, this 3 goes to 1, that 3 goes to 1, we shall end up having a half B. Implying that my BE in this case is supposed to be 1 out of 2B. Therefore, I've got the vector of BE as that one. Our first part was telling us that we should find the value of CB, which we got as 2A, the value of SC, which we got as B plus A, the value of BE, which we have got as a half B. Is it okay? Now, the second part of this question was asking us that we should show that the line D, F, E are collinear. When they say line are collinear, what do they mean? They mean this line, they should be on the same line. They appear in a straight line. In simple terms, they are parallel to each other. If they are parallel, they should have the same vector by different color. In this case, we want to find out that these points here, we want to show that they fall on the same line. But remember, what we are going to do in this case, we are going to find the vector of GF, and then we find the vector of FE. Let's see how we can work out those two vectors. I think we may need some more space in this case, what we can solve this one. Let's start with give. If you start with give, if you come here, G to F. To get GF, we may move from G to C and CF. I think that we're going to have GC plus CF. But here, to get GC, this is the same as saying 1 out of 3 of SC. Since we have our SC somewhere here, but we know that at GC to be the same as saying a half is going to be a third of SC, because this is 1 out of 3 of SC. And in this case, our SC, we have it here, it's going to be our GC to be the same as 1 out of 3 into bracket, which is B plus A. That is our GC. Also need to get our CF in this case. CF is going to be, C to F is going to be a half of CB. Is it okay? It's going to be a half of CB. In this case, we shall have 2. Our CB, we got it as negative to A. It's going to be times negative to A. Is it okay? And simplify this one, this goes to 1, therefore we shall end up having our CF as negative A. This gives us the vector of CF, and also we have the vector of G or CG, which are going to substitute back in this expression so that we can get our VF in this case. I think I can rub off this part so that we can have more angle space, but note the value of CB, note the value of SC, and also note the value of BE, because we may need it in our expression as we follow. Now, let's solve what you call GF. GF is going to be GC plus CF, whereby our GC in this case, it was that one, which is a third into B plus A, plus our CF was supposed to be negative A. Now let's simplify this one and you see what we get as our answer. And see what we get as our answer. If you enter the bracket here, we are going to end up having B out of 3 plus A out of 3 plus negative A. Correct like terms will give us here 1 out of 3B plus A also is going to be 3A minus 3A. Here if we simplify, it will give us a third B plus, if we simplify, it will give us negative A, negative 2A out of 3. If we factor out, it will be 1 out of 3 into bracket B minus 2A. Therefore here, our answer is supposed to be our GF is the same as a third into bracket B minus 2A. This one gives us the vector of DF. But remember, we said that to show that the lines are collinear, they form the same line, our main point is to calculate the DF, then after we calculate FE. We have got our DF as that one. Now let's try to calculate also our FE. I think I can rub off this part so we can have more space for our further calculations. Okay, when you come to get our FE, F to E. To get FE, we can move from FB to BE. I think that here you choose a direction whereby you can solve it so easily. Because you have two options. One may decide to come up and then come down. But when you use this route, remember you have CE. CE you have not calculated it. It may be hard for you to do it. But if you come and use this side of FB plus BE, it becomes so easier because you have BF somewhere, so you have BE. In this case, we are going to come and say B, it's going to be FB plus BE. Therefore, my dear students, here you come and apply my BE, which is going to be a half of, because it is FB, a half of CB plus BE, which you got it, which you have it here, which is a half of B. Now here, my CB, remember our CB, it was negative. If you recall what was our CB was negative 2A. It's going to be here. So have a half to negative 2A plus a half B. In simple term, we shall factor out to a half because it is a common factor. We shall have a half out into negative 2A plus B. Now in this case, we can rearrange and we shall have something like a half into B minus 2A. Now in this case, our FA is equals to a half into B minus 2A. Now, if you look very critical enough, you are saying that FE and DF, they are the same. They have the same vector and have different scalar. Here the scalar is a half, and here the scalar is a third, but the vector is B minus 2A, and here it is B minus 2A. Now, if that thing appears, then you conclude by saying the point G, F, and E are collinear. Reason being, they have the same vector. Therefore, we shall say, points G, F, E are collinear because they have the same vector. Is it okay? That's how we conclude in that case. My dear students, let me hope you have understood how we have worked out this number. You know, such numbers, they're a bit confusing, but let me hope you have understood how to do it. I think let's do number 2 and see how we can solve it also. Okay, let's stop here.